So how do we know who ought to produce something? Said another way, how do we decide who should specialize in the production of one good or another? Well, the answer, of course, is comparative advantage. But in order for us to know who has comparative advantage, we have to first know what it is. So let's remind ourselves that absolute advantage refers to the ability to produce more or better than another producer. So if you can make more stuff more efficiently, you have the absolute advantage. But economists, ever since the writing of David Ricardo, which British economist from hundreds of years ago, ever since then, we focused more on comparative advantage, which is a little different. Who can produce at lower opportunity cost? Not who does it better, but who can produce at lower opportunity cost? We will see that those are not necessarily the same thing. Let's work through an example to explore it. So we've got here Frank the farmer and Ruby the rancher. Frank produces meat and potatoes, and Ruby produces meat and potatoes. And we see their production possibilities frontiers for the production of both of these goods right here. So we should notice, remember that a PPF, a production possibilities frontier, shows all possible combinations of two goods that an economy, or in this case, an individual producer, can produce. So if Frank only makes meat, he can make 8 ounces. That's the y-intercept. And if he only makes potatoes, he can make 32 ounces. If Ruby, the one on the right, makes only meat, she can make 24 ounces of meat. And if she only makes potatoes, she can make 48 ounces. So let's look here. Who has absolute advantage in production of meat? Who can make more meat if all they make is meat? You guys should immediately see Ruby has absolute advantage in production of meat. Who has absolute advantage in production of potatoes? Well, Frank can produce 32 ounces. Ruby can produce 48. Ruby also has absolute advantage in production of potatoes. So the question becomes, okay, Ruby can make more meat or more potatoes than Frank. She couldn't possibly benefit from trading with him, right? Well, what we'll see perhaps is that even if you're better at everything than another producer, it's still in your benefit. It's still in your best interest to trade. So let's do a little bit of math here to determine opportunity cost. So in order to determine comparative advantage, who has lower opportunity cost, we first have to calculate opportunity cost. So we're going to do that. Now we could do that by calculating the slope of these production possibilities frontiers. That's one way to get there, but I'm going to show you a different way to get there. So zooming in on the most of either of these that they could produce, we've got Frank the farmer and Ruby the rancher with these numbers we just talked about. If Frank only makes meat, he can make 8 ounces. If he only makes potatoes, he can make 32 ounces. If Ruby only makes meat, she can make 24 ounces. If she only makes potatoes, she can make 48 ounces. With only these numbers, we can determine the opportunity cost of each product, producing each product for each farmer, and we can determine, necessarily then comparative advantage because we'll have opportunity cost numbers for both of these. So let's go to the marker board and try and solve this out a little. All right, so we've got a total of 4 calculations we're going to do here. Frank's opportunity cost of producing 1 ounce of meat, Frank's opportunity cost of producing 1 ounce of potatoes, Ruby's opportunity cost of producing 1 ounce of meat, and Ruby's opportunity cost of producing 1 ounce of potatoes. It's actually really important if you're calculating these for a homework or a test. I really recommend go ahead and write these out just like this so you don't get confused on what you're calculating, okay? So if we want to know Frank's opportunity cost of 1 ounce of meat, our calculation is going to be super duper simple. All we have to do is take the most of the other good that he can make, in this case, 32 ounces of potatoes, over the most meat he can make, 8 ounces of meat, 32 over 8 to get that 1 ounce of meat costs Frank 4 ounces of potatoes. 1 ounce of meat costs Frank 4 ounces of potatoes. And if you just look at these numbers for 2 seconds, that should be pretty obvious, right? 32 ounces is the most potatoes he can make. 8 ounces of meat is the most meat he can make. So if he's choosing one or the other, every time he chooses to produce 1 ounce of meat, he gives up the chance to produce 4 ounces of potatoes. Let's do the next one. Frank's opportunity cost of 1 ounce of potatoes. The most the most meat he can make is 8 ounces of meat. The most potatoes he can make is 32 ounces of potatoes. And we solve this 8 over 32. Every time Frank chooses to produce 1 ounce of potatoes, he gives up the chance to produce a 1/4 ounce of meat. I hope this is making sense for everybody. I'm going to try not to cover our answers over here. Again, how are we doing this? We're figuring out what one of these costs in terms of the other good. So the cost of meat is measured in potatoes. The cost of potatoes is measured in meat. It wouldn't make any sense to have potatoes here and here. 1 ounce of potato costs a 1/4 ounce of potatoes. That doesn't make any sense. The other thing we need to note here, we want the thing we're calculating for to be the denominator. We want the thing we're calculating for to be the denominator. If it's helpful to you, you could think of this as we're taking the average cost of 1 ounce of meat in terms of potatoes. So we put all the potatoes we can make and find the average by dividing by the number of meat we can make, if that's helpful. Another way you can think of it is we want the cost in terms of potatoes, so we do like you would in chemistry. Oh man, you guys remember chemistry? You do dimensional analysis to get from like meters to centimeters or inches to feet, right? Well, you go from this unit to that one. In order to get this in terms of potatoes, we have to divide out the units. So we want this on the bottom. However you want to think of it, this thing is your denominator. The thing you're solving for is your denominator, right? All right, hopefully that's making sense to you guys. Ruby's opportunity cost of 1 ounce of meat is next. Again, we're going to set up a fraction. We want the most meat she can make. If this is what we're solving for, we want that on the bottom. The most meat she can make is 24 ounces of meat. The most potatoes she can make is 48 ounces of potatoes. And we solve this. 48 over 24 is 2. 1 ounce of meat costs Ruby 2 ounces of potatoes. Ruby's opportunity cost of producing 1 ounce of potatoes. Well, we put the potatoes she can make on the bottom, because we're solving for this one. We want it in the denominator. 48 ounces of potatoes. We put the other one on top, the thing we're solving for, 24 ounces of meat. And we solve this thing, the most meat she can make over the most potatoes she can make, 24 over 48, we get 1/2 ounce of, this is cost of potatoes, and we measured it in meat. Every time Ruby chooses to produce 1 ounce of potatoes, she gives up the chance to produce 1/2 ounce of meat. So, we have solved for opportunity cost for both producers in the production of both goods. I want to make a couple quick notes here. One, immediately you should recognize, okay, now I have opportunity cost for production of meat, and potatoes for my two producers. Comparative advantage is lower opportunity cost. Who has lower opportunity cost in production of meat? Here's Frank's opportunity cost of 1 ounce of meat. Lower opportunity cost. His 1 ounce of meat costs him 4 ounces of potatoes. Ruby's 1 ounce of meat costs her 2 ounces of potatoes. So who has lower opportunity cost? Ruby's opportunity cost of 1 ounce of meat is only 2 ounces of potatoes compared to Frank's 4. So Ruby should make the meat. Frank's opportunity cost of producing 1 ounce of potatoes is a 1/4 ounce of meat. Ruby's opportunity cost of producing 1 ounce of potatoes is a ½ ounce of meat. A quarter is less than a half, so Frank should produce the potatoes. Frank has comparative advantage in production of potatoes. Ruby has comparative advantage in production of meat. Another thing we should notice here. Notice these fractions are literally just flipped, right? Of course, you probably already noticed that as we went through. So if this number is bigger than this number, meaning that Ruby has the comparative advantage in that good, if we flip both these fractions, we get the reciprocal of these numbers. 4 becomes a quarter, 2 becomes a half. Well, if this one's bigger than this one, then when you flip them and put 1 over, well, then now the denominator is bigger. So then the other one's going to be bigger once you take the reciprocal. Why do I say that? Maybe that's confusing you. I'll put it very simply. It is mathematically impossible to have comparative advantage in production of both goods. You can have absolute advantage. You can be better at making everything, but you can't have lower opportunity cost in making everything, okay? Mathematically impossible to have comparative advantage in both goods. So we never ever want to put down that one country or one producer has comparative advantage in both goods. It cannot be the case. All right, let's send it back to the PowerPoint. So we can see here that our numbers agree with the numbers here in the slideshow. Frank the farmer, every 1 ounce of meat costs him 4 ounces of potatoes. Ruby the rancher, every 1 ounce of meat costs her 2 ounces of potatoes. And Frank the farmer, every 1 ounce of potatoes costs him a quarter ounce of meat. And Ruby the rancher, every 1 ounce of potatoes costs her a quarter ounce of meat. So who has the lower opportunity cost in production of meat? Well, if it costs Frank 4 ounces of potatoes to make 1 ounce of meat, and it costs Ruby 2 ounces of potatoes to make 1 ounce of meat, then we should see that Ruby has the lower opportunity cost in production of meat. And what about in production of potatoes? Well, for Frank, his opportunity cost of producing 1 ounce of potatoes is a quarter ounce of meat. And for Ruby, her opportunity cost of producing 1 ounce of potatoes is a ½ ounce of meat. A quarter is smaller than a half. So Frank has comparative advantage in production of potatoes. All right, so what do we care? We said comparative advantage is what we should use to decide who should produce what. We want to use comparative advantage. Does this actually mean anything? Does this actually do anything? Well, the big reveal here, if we allow these producers to trade, you guys notice we have for each of these, Frank and Ruby, those same PPFs, and at point A for Frank and point B for Ruby, without trade, they get to consume some combination of meat and potatoes. You can see Frank's and Ruby's there. But by specializing in what they are relatively good at, again, what they have lower opportunity cost in, and then trading, we can see that Frank is able to reach past what is possible for him to produce on his own and get point A star, more meat and more potatoes. Now you may be thinking, of course he can. He was worse at both. But even Ruby, even though she was better at both, she still gets, by trading, to have more meat and more potatoes. Trade, we see, is making both Frank and Ruby better off. Trade, we see, is creating wealth. Trade is making both of our producers better off. And again, we see this over and over again. Of course, there's nuance, there's caveats, there's subtlety to this, but in general, voluntary exchange and trade between individual producers or different peoples and places of the world is usually to the benefit of those engaged in the trade. All right, well, we'll call it there for today. Thank you all so much. Bye-bye.